We're here at go2math.com. Click on the calculus. Go down here, click on finding the area between curves, and we're doing 2.2. Alright. Find the area of the shaded region. Click here to renew problem if you want. Okay, so there's no function here, so we're going to have to come up with a function that represents this line and then one for this line here to figure out what the shaded region is. Now let's just talk about this quickly. So what we're going to be doing here is we're going to find the area between 0 and whatever this is. Let's count over. So one thing we have to assume here, this is 1 unit. Each one of these one unit here. And since all the rest of the graphs are, this one is too. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we're going between, our interval is between 0 and 13 for that one. 0 and 13. Alright. And let's go ahead and count up. And do we need, yeah, we need this interval here too. Let's see, 1, 2, 3, 4. Let's go ahead and write that down too. So 4. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Somebody write that down. 16. And it looks like 17 is the top one. Okay. And the reason we need to know that is because f of x we'll call is equal to 17. Alright, is equal to, we said this was 17, I hope. I really don't want to recount that. So f of x equals 17, this is just a constant. Alright. Well, anyway, what we're going to be doing here is we're going to find the area between 0 and 13, finding the area under this curve here. Alright, so we find this total area, and then we subtract off this area here, this white region of the triangle, subtract that off, and then that'll leave us with the green shaded region. So we're going to have two separate integrals here, as you can see. Alright, now we've already got the we've already got this function here. We know what this is, fx equal to 17, but we need to figure out what this one is here, and that's pretty easy to do. We know the y-intercept. We know that it crosses right here at what did we say, 16, right? This is 16. If this is 17 right here, this must be 16 obviously. So we know the y-intercept is 16. And to get the slope, we can start here, and since we're counting down to the origin, that would be in the negative direction, so we'd end up with a negative number. Well, this ends up, since this is 16 units, it's negative 16, and then we count over 1, 2, 3, wait a minute, 1, 2, 3, 4, count over 4. Yeah. And that actually intervals between 0 and 4. I don't know. I wrote 4 and 16 down. Not sure why. But oh, that was this guy here. But never mind. Okay, so this is 4. So this would be negative 16 over 4. We got all those numbers down. Negative 16 over. That's going to be our slope. And then, of course, our y-intercept is 16 right here. Let's just go ahead and move over to the whiteboard. I think I've said enough there. So that top one we'll call f of x is equal to 17. And then g of x, we know the slope is negative 16 over 4 plus, and the y-intercept is 16. And of course, we can actually reduce this down, right? Like that right there. Okay. let me just go ahead and sketch that graph out. All right. Okay, so we had the constant here, passes through 17, and then we had the right triangle, comes down to something like this. Okay, this is obviously not to scale. And then we're coming over. Okay, all right. We'll actually use some green ink there. All right. So this right here is what we're trying to find the area of. Okay. And all right, if this is 6, okay, I believe this right here. Let's see, the interval between 0, no, this must be 13 here. I've got it written down on my piece of paper here from between 0 and 13. And then, of course, like I said, this is obviously not to scale. And then this is 4 right here, from 0 to 4. So we're going to find this area first. All right. And then we'll find this area and take the larger area minus this area here, and then we'll be left with the green shaded region. All right. So let's do the larger area first. So we're going from 0 to 13. And of course, right, this is what we're looking at. This is what we're integrating under. So 17 dx, and then that's the larger area minus, right, the area of this right triangle here from 0 to 4. And of course, negative 4x plus 6 is our integrand dx. All right, so that's it. I want to check a few things here. 1, 2, 3, 4, 10, 11, 12, yeah, 13. Just making sure. Alright, so that's how you set that up. Now you should know how to take the integral of both these pretty easily. Okay, and that would end up representing this area here. But we'll go ahead and do that. So we have 17x going from 0 to 13 minus, and then start a parentheses here, negative 4x squared over 2 plus 6x, and we're going from 0 to 4. So I'm going to take it that you know how to take the integral of these guys. If not, you need to go back to the sections where I do that, and that would be under the definite integrals. Alright, so let's look at this. So plugging in 17 times 13, okay, that's obviously the area of the big piece, minus, now look here, we can simplify this down a little bit, that's a 2. Don't worry about that minus sign just yet. Alright, so this becomes, we're going to start parentheses here, so this becomes negative 2 times 4 squared. We're plugging in the 4 here. I think there was something I didn't mention here. Plugging in the 0, right, we just get 0, so I didn't even write it in. All right, plus 6 times 4. And then, of course, we go minus, plugging 0 in, we just get 0. All right, so don't worry about that. And technically, we'd probably do something like that. Okay. Does anybody know what that is? 17 times 13, 170, whatever. Let's see, 17 times 13, 221. Minus, so this is 16, this is 32, negative 32, plus 24, it looks like. Whoops, so 16 and 2. Okay, negative 32. 32 plus 24, you get negative 8 But because of this negative right here, it becomes a plus 8. So let's just go ahead and skip that step, right? And wait a minute. What did I say? Get negative 8 and negative and a negative is positive. Well, that's what I'm getting. Doesn't make sense, but we got to go with it. 229. Something's fishy going on here I'm not seeing. Some reason. Negative, let's see, 416 plus 24. 32, that's a negative number, and negative is, I don't know, we're going to have to go with it. I see something here. I'm like going, man, something's fishy here. I left this off. So, I thought about redoing this video, but even after doing math for a long time, you still got to watch out for the details. Anyway, I left off 16, so let's throw a 1 in here. Let's make that a 16. Alright, this makes more sense. I'm like, we should be subtracting off, not adding to. So making an adjustment or two here real quick. Alright, so we end up with, that's definitely not right. So let me go ahead and erase. Okay. My intuition was telling me something was not right with that picture. Okay, so we had 16 times 2 is negative 32. Plus 16 times 4. That's the reason you got to kind of back up and use some common sense sometimes. Right, so that becomes 32. So this minus, like it's supposed to be, 32. Alright. Okay, so we got 221 minus 32. 189. So we got a total here of 189. Alright, let's move over. I'd already clicked that. 189. So that's what we got. 189. Of course, it's area, it's square units, but we're not putting that in there. All right. So come on by, practice that. That's real world problem stuff there. You're not given the functions, you got to derive them. Especially if you're trying to find, this could be the area of a kitchen, right? The area of a kitchen. And you want to find how many square feet, and for some reason it's cut like this, how many square feet of tile or whatever, you know? Probably wouldn't use calculus, we just use some simple geometry formulas. But we're about to get into some really cool stuff here in a minute. Alright, let's go on over to go to math.com, check it out, see you there, bye.